This is activity 3, hot dog eating contest for lesson 13, 2 graphs for each relationship. And this is a hot dog eating contest between Andre and Jada. And the question is, who's eating hot dogs faster? And you can look at the relationship of the hot dogs to time in 2 ways. One way, these are the 2 graphs or the 2 equations. One way is to look at the number of hot dogs eaten over the time, so the number of hot dogs per minutes. The other way to look at this relationship is how long does it take, the number of minutes, to eat hot dogs. So this is minutes per hot dogs. This is hot dogs per minutes. And the idea is to get these relationships to in a form in which you can tell who's eating the hot dogs faster. So let's look at hot dogs per minutes first. So Andre eats 10 hot dogs in 3 minutes. Jada eats 12 hot dogs in 5 minutes. And so what you want to do is get this to how many hot dogs does each of them eat in the same amount of time. And that same amount of time is 1 minute. If you can get each of them to 1 minute, you could get them both to 3 minutes. You could get them both to 5 minutes. But 1 minute comes from the way you set up the problem. So let's go back. This is what we learned in the last activity. If for Jada, if she eats 12 hot dogs in 5 minutes, 12 hot dogs in 5 minutes, if she takes 1/5 the time, so 1 minute, she's going to eat 1/5 the number of hot dogs. So that's 12/5 hot dogs in this 1 minute. So the 12/5 is the same as 2 2/5 hot dogs in 1 minute. So this is Jada's graph right here. And so she's eating hot dogs at a rate of 2 2/5 hot dogs in 1 minute. So I'm going to show you this 1 minute in just a second. And the equation for Jada's rate of eating hot dogs is y over x, which is 12 over 5. That's this 12/5 right here. This is the constant of proportionality times the number of minutes. So 1 minute is 12/5 hot dogs. 2 minutes is 2 times 12/5. 3 minutes is 3 times 12/5, and so on. For Andre eats 10 hot dogs in 3 minutes. So 10 hot dogs in 3 minutes. Well, how many hot dogs is that per minute? So if you look at 1/3 the time, which is 1 minute, that's 10/3 hot dogs in that 1 minute. So that's 3 1/3 hot dogs per minute. So Andre is eating more hot dogs in that 1 minute than Jada. So Andre's graph is steeper. So he's eating hot dogs at a faster rate, hot dogs per minute. He's eating 3 1/3 hot dogs in 1 minute. Jada's eating 2 2/5 hot dogs in 1 minute. So you just have to keep going over this and keep saying it to yourself, and it will become clear. So we're going to go over this relationship in the reciprocal way. So we're reversing the axes. So now this is time in minutes per hot dogs. So we're going to get this relationship down to how long does it take to eat a single hot dog. And you're going to start to understand that who's ever eating a single hot dog in a faster amount of time, in a shorter amount of time, I should say, they're eating those hot dogs faster. And we know that that's Andre. Because back here, Andre is eating hot dogs faster, so it should take him a shorter amount of time to eat a single hot dog. So the same idea. So let's look at Jada first. Jada is taking 5 minutes to eat 12 hot dogs. So 5 minutes to eat 12 hot dogs. Well, if you look at 1/12 the number of hot dogs, so you look at 1 hot dog, that's 1/12 the time it takes to eat that 1 hot dog. So Jada eats 5/12 of a hot dog. Jada takes 5/12 of a minute to eat 1 hot dog. So if you look at 1/12 the number of hot dogs, it's going to take 1/12 the amount of time. So that's 5/12 minutes. So 5/12 minutes per 1 hot dog. So 5/12 minutes it takes Jada to eat a single hot dog. So her equation for minutes per hot dogs is right here. So the constant of proportionality is 5/12. So it takes 5/12 minutes to eat one hot dog. It takes 2 times this to eat 2 hot dogs, 3 times this to eat 3 hot dogs, and so on. So for Andre eats 1 hot dog in 3 minutes. So it's 3 minutes per, 10 hot dogs in 3 minutes. So it's 3 minutes per 10 hot dogs. So if you take 1/10 the number of hot dogs, so 1 hot dog takes 1/10 the amount of time. So that's 3/10 minutes per 1 hot dog. Whereas Jada is 5/12 minutes per 1 hot dog. And so Andre is eating that 1 hot dog in a shorter amount of time, 3/10 of a minute, whereas Jada is taking almost a half a minute. 6/12 would be a half a minute, which would be 5/10. 5/12 is just a little bit less than half a minute, but nonetheless, Jada is still taking a longer amount of time to eat that 1 hot dog than Andre. So this makes sense with what we did a moment ago. All right, so let's look at the equations for this, and we're going to go use this relationship first. So number of hot dogs per time. So Jada is 12 hot dogs per 5 minutes, and that's 12/5 hot dogs per minute, and Andre is 10 hot dogs per 3 minutes, or 10/3 hot dogs per minute. 10 hot dogs per 3 minutes, or 1/3 that amount of number of hot dogs is 10/3 hot dogs in 1 minute. All right, so Andre's equation, going back to here, right here, we're looking at this relationship right here. 10 hot dogs per 3 minutes. So 10 hot dogs per 3 minutes is 10/3 hot dogs in 1 minute. So 1/3 the amount of time, 1/3 the number of hot dogs. So the number of hot dogs Andre eats is 10/3 hot dogs per minute, or in 1 minute. So his constant of proportionality is 10/3. So Andre eats 10/3 hot dogs, which is 3 1/3 hot dogs each minute. So think about that. A minute goes by, he eats 3 1/3 hot dogs, which equals 10 hot dogs in 3 minutes. So 1 minute goes by, he eats 3 1/3 hot dogs. 2 minutes goes by, that's 6 2/3 hot dogs. 3 minutes goes by, that's 9 3/3 hot dogs, which is the same as 10 hot dogs in that 3 minutes. So what does Jada's relationship looks like? She eats 12 hot dogs in 5 minutes. So again, she is right here. 12 hot dogs in 5 minutes. So that's, if you take 1/5 the amount of time to get to 1 minute, she's going to eat 1/5 the amount of hot dogs. That's 12/5 hot dogs in 1 minute. So her equation is, the constant of proportionality is 12/5 hot dogs every minute. So its number of hot dogs is 12/5 the time. So however amount of time she takes, the number of hot dogs is 12/5 that time. So if this is 2 minutes, it's 12/5 times 2. 3 minutes, 12/5 times 3, and so on. So Jada eats 12/5 hot dogs, which is 2 2/5 hot dogs each minute, which equals 12 hot dogs in 5 minutes. So again, picture what's going on. So 1 minute goes by, she eats 2 2/5 hot dogs. 2 minutes go by, she eats 4 4/5 hot dogs. 3 minutes goes by, she eats 6 6/5 hot dogs, which is 7 1/5 hot dog. I'm going to get mixed up. I keep doing this. 4 minutes is 2 times 4 is 8 8/5, which is 9 3/5. And go to 12 minutes goes by is 5 minutes goes by is 2 times 5 is 10 hot dogs, and 5 times 2/5 is 2 more hot dogs. So that's going to be 12 hot dogs in 5 minutes. Sorry about that. Got a little bit confused there. All right. So let's look at the equations for the other relationships. So now we're looking at amount of time to eat hot dogs. So this is 5 minutes for 12 hot dogs for Jada and 3 minutes to eat 10 hot dogs for Andre. So Andre is 3 minutes per 10 hot dogs. Or if you take 1/10 the number of hot dogs, which is a single hot dog, it's going to take 1/10 the amount of time. So this is 3/10 hot dogs in 1 minute. I'm sorry. 3/10 minutes per 1 hot dog. So this is 3 minutes per 10 hot dogs, 1/10 the number of hot dogs. It's 1 hot dog in 3/10 of a minute. So his constant proportionality for this relationship is 3/10. So the amount of time is 3/10 the number of hot dogs. So 1 hot dog takes 3/10 of a minute. So Andre takes 3/10 minutes to eat 1 hot dog, which is the same as 3 minutes to equal 10 hot dogs. It's just 10 times 3/10. So 3 minutes to equal 10 hot dogs. Jada, on the other hand, takes 5 minutes to eat 12 hot dogs. So 1/12 that number of hot dogs is a single hot dog. So it's going to take 1/12 the amount of time. So this is 5/12 minutes per 1 hot dog. So the constant proportionality is 5/12 times the number of hot dogs. If it's 1 hot dog, it's 5/12 of a minute. 2 hot dogs, 2 times 5/12, 3 times 5/12, and so on. So Jada takes 5/12 minutes to eat 1 hot dog, which equals 5 minutes to eat 12 hot dogs. It's 12 times 5/12 minutes per hot dog. So 12 times 5/12 is 5. 5 minutes to eat 12 hot dogs. I started to use this diagram to look at both of these relationships at the same time. So for Andre, there's 2 graphs, 2 equations, 2 relationships. So in 1 minute, so this whole circle is going to represent 1 minute right here. Andre eats 3 1/3 hot dogs. So this is 1 hot dog, 2 hot dogs, 3 hot dogs, and 1/3 of a hot dog in 1 minute. So 1 minute goes by, Andre eats 3 1/3 hot dogs. So how long does it take him to eat 1 hot dog? It takes 3/10 of a minute. So 3 1/3 hot dogs per minute is 10/3 hot dogs per minute. And so the amount of time it takes him to eat 1 hot dog is the reciprocal of 10/3. If he's eating 10/3 hot dogs or 3 1/3 hot dogs in 1 minute, then he's eating 1 hot dog in 3/10 of a minute. The reciprocal or the multiplicative inverse. And that's right here. So 3/10 minutes for 1 hot dog, 10/3 hot dogs per minute. So think about what's going on here. As he goes around this circle for 1 minute, he's eating 3 1/3 hot dogs, but it only takes 3/10 of that minute to eat 1 hot dog. Now if you compare that to Jada, in 1 minute, Jada eats 2 2/5 hot dogs. 2 2/5 hot dogs in 1 minute. That's 12/5 hot dogs per minute. So in 1 minute, Jada eats 1 hot dog, 2 hot dogs, and 2/5 of a hot dog. So 2 2/5 hot dogs in that 1 minute. But how long does it take her to eat 1 hot dog? It takes 5/12 of a minute. It's the reciprocal. 5/12 of a minute to eat 1 hot dog. So 5/12 of a minute to eat 1 hot dog, 5/12 of a minute to eat a second hot dog, and 2/12 of a minute to eat 2/5 of a hot dog to get to that last part of the minute. So now if you look at this relationship, first of all, this is more hot dogs in the 1 minute. This is 3 1/3 hot dogs in a minute. This is 2 2/5 hot dogs in a minute. And to eat 1 hot dog, this is a shorter amount of time. This is 3/10 of a minute. This time right here is 5/12 of a minute. So this is a shorter amount of time to eat that one hot dog. And finally, the way that I set these up is I looked at the number of parts here. This is 10 parts because it's one hot dog in 3/10 of a minute. So I know I'm going to need tenths. 3/10, 3/10, 3/10, and 1/10, because I know that I'm going to complete 1 minute, and those are going to be tenths of minutes to equal the parts of the time per hot dog. Down here, I knew that I had to divide this circle up into twelfths, because it's 5/12 of a minute, 5/12 of a minute, and then 2/12 of a minute for this last part. And you can get that from this relationship. It's twelfths, so you have to divide this up into twelfths, or it's 12/5 hot dogs per minute. So I know I'm going to eat 12/5. So I need to look at those 12 parts. I know I'm going to eat, or Andre is going to eat 10/3. So you have to look at those 10 parts. So this is 3 of those parts, 6 of those parts, 9 of those parts, and 1 more is 10. This is 5 of those parts, 10 of those parts, and 2 more parts is 12. So I'm going to go over this. I like this kind of drawing, so I'm going to go over this more and talk more about how you make this diagram. I like it because in one diagram you see the reciprocal relationships.